Welcome to our tutorial on 10 powerful Python one-liners that every data scientist should know. Let's explore how to efficiently handle missing data in Python with a powerful one-liner. Missing data is a common issue in data science, and Python offers quick solutions for it. In data science, handling missing values is a common challenge that requires efficient and reliable strategies. By using Pandas one-liners, we can quickly identify, visualize, and impute null values across entire datasets. We begin by importing the essential libraries Pandas and NumPy needed for data manipulation and handling missing values. Next, we create a sample data frame with intentional missing values across different columns to illustrate the missing data problem. The core one-liner handles missing values by first filling them with column means, and for any remaining nulls, applies a forward fill imputation to maintain data integrity. Finally, we print both the original and cleaned data frames to compare the results and visualize the impact of our missing data handling strategy. Here you can see the output showing the original data frame with missing values, followed by the clean data frame where all missing values have been intelligently filled. Next, we'll see how to remove highly correlated features in a single line of Python code. Let's explore how removing highly correlated features can enhance model performance by reducing multicollinearity and simplifying the dataset. Let's see how to generate a dataset with correlated features for our demonstration. Here we use NumPy and Pandas to create several random numerical features. To introduce high correlation, Feature 4 is created as a combination of Feature 1 with some added noise. Now let's analyze correlations and prepare to drop redundant features with this one-liner. Finally, we print both the complete correlation matrix and a list of any features that should be removed due to high correlation. Next, let's explore how to apply conditional logic to transform data frame columns efficiently. Data scientists often need to create new columns or modify existing ones based on specific conditions. Advanced data transformation often involves applying different operations depending on conditions, and this powerful approach makes it possible to modify multiple columns efficiently in a single line. Let's start by creating a simple dataset with numerical values and categories. Now we'll apply a conditional transformation using NumPy's where function to efficiently create a new column based on each row's category. To check our result, we print the original and transformed data frame side by side. Here is the output, showing how the transformation differs for each category in a single, concise step. In this section, we'll learn how to quickly find shared and unique elements between Python collections using powerful one-liners. Set operations in Python make it effortless to compare lists or arrays for overlaps and differences. Set operations allow us to quickly find elements that two datasets have in common or that are unique to each set, which is a common task in data analysis. We begin with 3 sample lists that we'll use to find common and unique elements. To find the common elements across all lists in a single line, we use the set.intersection method combined with map to convert each list to a set. For unique elements, we calculate the union of all sets and subtract the intersection, again using one powerful line. Finally, we print the results to see both the common and unique elements produced by our one-liners. The output confirms that 4 is the only common element, while all other elements from the lists are unique. Let's dive into using Boolean masks for powerful and efficient data filtering in Python. Boolean masks are arrays of true and false values used to select specific rows or elements from data structures based on conditions. Boolean indexing is a powerful tool for efficiently filtering datasets based on multiple complex conditions. We start by creating a simple data frame representing some people, their ages, and scores. Here's the one-liner that filters the data frame using a complex condition, efficiently combining logical and or masks. After filtering, we print the original and the filtered data frames to clearly display the results. The output shows which rows satisfied the filtering conditions, keeping only those that match our logical rules. Let's explore a powerful Python one-liner to quickly count item occurrences in a list for fast frequency analysis. We start by importing the counter class from the collections module for convenient frequency counting. A sample list with repeated items is created to demonstrate how the one-liner works. This concise one-liner instantly counts each item's frequency in the list and returns a dictionary-like counter object. Printing the result displays the count of each unique element in the list, offering a quick snapshot of item frequencies for your analysis. Counting how often each element appears in a list is essential for efficient data analysis. We can use a dictionary comprehension to quickly calculate both frequency counts and percentage distributions for list elements in one line. Let's look at how you can efficiently count occurrences and calculate percentages for each element in a list using a concise Python one-liner. Here we create a dictionary where each unique element's count and its percentage of the total are stored together, all in a single dictionary comprehension. The next block prints out the frequency distribution, showing each item alongside its count and percentage. As you can see from the output, each element of the list is clearly reported with its frequency and the corresponding percentage. Let's dive into extracting numbers from text with a concise and powerful Python one-liner. First, we import the regular expressions module, which is essential for pattern matching in text. Suppose we have a list of texts with embedded numbers that we want to extract. This one-liner uses a list comprehension and the findAll function to extract all numbers from each string as integers. Finally, we print the extracted numbers to see the results for each text entry. Extracting numbers from text is a common data science task, especially when dealing with messy or semi-structured data. By using regular expressions and list comprehensions together, we can efficiently locate and isolate numerical values from text strings in a single line of code. Let's start by importing the regular expressions module and defining a list of sample text containing numbers. Here we use a one-liner that applies a regular expression to each line, extracting every number, including decimals, and converting them to floats. This enhanced version associates each extracted number with its label by splitting on the colon and capturing the first number found in the text. Finally, we print the list of all extracted numbers, as well as the contextual dictionary mapping labels to values. Now let's explore a concise one-liner for flattening nested lists, a common data manipulation task in Python. Here's a sample nested list, structured with multiple levels of sublists. This one-liner uses a nested list comprehension to flatten the list, extracting each item from all inner lists into a single list. Running this will print out the flattened version of your nested list, making it easier to process or analyze. Dealing with nested lists is a frequent challenge in data processing tasks. A recursive approach allows us to flatten lists of any depth into a single simple list using list comprehensions and generator expressions. Let's explore how to flatten deeply nested lists in Python using powerful one-liners. We start with an example of a nested list containing numbers and sublists within sublists. This one-liner uses a lambda and a generator expression to recursively flatten any nested structure. Alternatively, here's another one-liner that flattens the list using recursion and the sum function for compactness. We now test both flattening functions and print the results to compare their outputs. Finally, the original nested list and the two flattened results are printed for easy verification. Both methods produce a flat list with all the values from the nested structure, as shown in the output. Let's explore a powerful Python one-liner for converting a list into a dictionary using dictionary comprehensions. Here we create a sample list of tuples, each with a key and a value, that we want to convert to a dictionary. The dictionary comprehension shown here iterates over each tuple in the original list and constructs a dictionary by unpacking the key and value from each tuple. Finally, we print the resulting dictionary to see the conversion result. Converting lists to dictionaries is a fundamental operation in data processing. This technique shows multiple ways to create dictionaries from lists while handling various data structures and maintaining data relationships. Let's explore several concise ways to convert different types of lists into dictionaries, starting with our sample data definitions. The first one-liner demonstrates how to map two lists, one of keys and one of values, into a single dictionary using the zip function. We can also convert a list of tuple pairs directly into a dictionary in just one line. When you have a list of objects, you can create a dictionary by comprehending over the list and extracting key-value pairs. To handle mismatched lengths, this advanced mapping fills in missing values with none so that every key has an associated value. Let's print and observe the output of each dictionary conversion technique for clear comparison. The output shows the results of each conversion, confirming the effectiveness of these one-liners for different scenarios. Let's explore how to merge multiple dictionaries into one using concise Python one-liners. We begin by defining several example dictionaries to demonstrate merging techniques. Here's a one-liner that merges multiple dictionaries using dictionary unpacking, combining their key-value pairs into a new dictionary. The collections.chainmap approach combines several dictionaries into a single, layered mapping that allows you to access keys from left to right. When using the pipe operator, Python 3.9 and above let you merge dictionaries in a clean and intuitive way. You can also merge dictionaries in place using the update method, which modifies the original dictionary and adds new key-value pairs. Each merged result prints a dictionary containing all key-value pairs, with values from later dictionaries overriding earlier ones when keys duplicate. Efficiently merging multiple dictionaries is crucial for combining different data sources in data science tasks. Advanced merging techniques can handle conflicting keys and preserve the integrity of integrated datasets, ensuring accuracy in your final results. Let's explore how to merge multiple dictionaries using 3 different Python one-liners, each with varying levels of depth and conflict resolution. We start by defining 3 sample dictionaries, each with both top-level and nested entries. The first merging approach uses dictionary unpacking to combine all keys and values, with later dictionaries' values overwriting earlier ones on key conflicts. Using chainmap, this second approach creates a merged dictionary that scans left to right for each key, with rightmost values taking precedence, but only at the top level. The advanced merge approach involves a recursive function that deeply merges nested dictionaries, combining subkeys instead of overwriting entire nested structures. We perform all 3 merges, simple, deep, and advanced, and print the resulting dictionaries to observe the differences in their outputs. Here's a side-by-side comparison of the 3 merging methods, each producing a different result, especially for the nested dictionary C. Let's see how these Python one-liners are applied in a real-world text data analysis scenario. Python one-liners can quickly extract and process numerical information embedded in text, making text data analysis fast and effective. Let's see how multiple Python one-liners come together to efficiently analyze customer reviews for insights. Let's dive into a practical example where we use multiple Python one-liners to efficiently analyze customer review text data. We begin by importing pandas, NumPy, and the counter class from collections for our data analysis tasks. Next, we define a small sample dataset containing customer review strings for our analysis. Now, we use a single dictionary to organize 3 one-line text analysis tasks, calculating word frequency, extracting ratings, and computing simple sentiment scores. Here we use counter and list comprehensions to quickly tally the frequency of each word across all reviews in lowercase. This next part extracts numeric ratings from review texts using regular expressions and converts them to floats for further analysis. For sentiment analysis, we count the positive and negative words in each review and subtract counts to assign each review a basic sentiment score. Finally, we print the top 5 most common words, the extracted ratings, and the resulting sentiment scores for our reviews. Let's see how we can apply Python one-liners to efficiently process and analyze time series data. Let's explore how Python one-liners can streamline and enhance your workflow with time series data. We'll see efficient techniques for resampling, computing rolling statistics, and detecting anomalies using concise vectorized code. Let's see how several Python one-liners can be combined for a powerful and efficient time series analysis workflow. We begin this workflow by importing pandas and NumPy and the datetime modules for handling time series data. Next, we generate hourly timestamps and create a pandas series of synthetic time series data. We construct a data frame that brings together several core time series features, each calculated in a one-liner. The daily average is computed using pandas resample and mean methods for each day within the hourly data. Anomalies are detected in a single line by checking which values deviate by more than 2 standard deviations from the mean. A simple trend line is calculated using NumPy's polyfit for polynomial regression, revealing the overall direction of the data. Finally, we print a preview of the analysis data frame, display the number of detected anomalies, and show the trend coefficient to summarize the findings. Let's briefly discuss performance optimization results for these Python one-liners and how they stack up against traditional, more verbose methods. Next, let's examine the performance benefits of using Python one-liners compared to more traditional coding approaches. This comparative analysis highlights measurable improvements in both execution time and memory usage when employing concise one-liner solutions for common data science tasks. Let's start by importing the necessary libraries and generating test data for the performance comparison. Here we define the performance testing function, which measures execution time and memory usage for each implementation. Next, we define 2 flattening methods, one using the traditional approach and the other using a recursive one-liner. We now run our performance tests and collect the results in a data frame for easy comparison. The printed output summarizes the execution time and memory usage for both the traditional and one-liner flattening approaches. Let's conclude with a collection of further learning resources to deepen your Python one-liner mastery. Let's wrap up with some valuable resources for mastering Python one-liners in data science. Explore these research papers for in-depth insights into efficient Python data processing and code optimization. The second paper offers a comprehensive analysis of one-line programming paradigms and their impact on performance. Delve into advanced Python optimization strategies for data science with the third recommended resource. Finally, the last paper compares various code optimization patterns in data processing tasks.